This is a simplex method question. It's a maximization problem with two variables, x and y. You can see we have these two constraints plus the usual non-negative constraints. It's non-standard because this one of the constraints is not a less than or equal type constraint. So that's what makes it a non-standard problem. So we're going to solve this with the simplex method. These two inequalities and this equation are the starting point for our simplex tableau. Because this is a greater than or equal inequality, we multiply through by -1 to convert it to a less than or equal inequality. For the two inequalities, we introduce slack variables, u in the first inequality, v in the second inequality. So with those two slack variables and the profit equation, these are the equations that provide the three lines of the initial simplex tableau. We'll have x, y, u, v, and p columns, and then the column on the right. So it will be a 3 by 6 matrix that makes up the initial simplex tableau. And the coefficients come from these equations. So make absolutely certain that you're completely clear on how you go from this information to this initial simplex tableau. When I put that initial simplex tableau into the row operations tool, this is what I have. Notice I've labeled the variables even. X and y, the original variables, u and v, the slack variables, and p, what I'm maximizing. So I have the minus number in the final column here, so that's what I have to look at first because it's a non-standard problem. Slide across from the minus 360 and stop at either of these places where I have a negative number. I'll just pick the minus 20 for convenience. These numbers look simple to work with. Check the ratios. Minus 20 into minus 360 is 18. 10 into 260 is 26. So minus 20 into minus 360 gives me the smaller positive ratio of 18. So that determines minus 20 as my pivot element. I pivot on the minus 20. That performs the row operations that make that spot a 1, the other spots in that column zeros. So I've completed my first step in the simplex procedure. I still have negatives in the bottom row, so I'm not done. I pick the most negative, which is the minus 3.3. So my next pivot column will be the first column. I'll pivot on either the 8 or the 0.7. I have to check ratios again. 8 into 80 is 10. 0.7 into 18 will be something bigger than 10, whatever it is. So 8 into 80 will give me my smallest ratio. I pivot on the 8, click pivot on selection, and I'm done. No more negatives in the bottom row. I just have to read off the solution that corresponds to this simplex tableau. And the solution is x is 10, y is 11, and p is 51. Let's come back to the original question and check out the solution that we just found with the simplex method. What we found was x equals 10, y equals 11, p equals 51. If you plug in x equals 10 and y equals 11, 15x and 10y is 150 plus 110, which is 260. So this constraint is satisfied. And the second inequality, 14x plus 20y, if x is 10 and y is 11, would be 140 plus 220, which is 360. So the second constraint is satisfied. So in answering the questions, the maximum value of P, 51. What's the corner point which maximizes the profit? X equals 10, Y equals 11. And then the final question is, if your slack variable for the first constraint is U and the second variable is V, then what value do the slack variables have? That requires us to go back and look at our final simplex tableau. In our final tableau, the U column and the V column were not in unit form. It's the X column, the Y column, and the P column that are in unit form. So these variables get set to 0, U equals 0 and V equals 0. So our final simplex tableau also gives us the value of the slack variables, U equals 0 and V equals 0. So that provides our answers for the two final blanks.